Hello guys, my name is Nathan Titimina and I'll be taking you through the simulation of our AC to DC converter. So we are converting our 230 volts AC to 5 volts DC. So in this course, I'm going to teach you how to build that circuit in Multism. So we're going to build it and simulate it right away. So make sure you prepare your environment and follow whatever I'm doing in this tutorial. To begin with, let us choose the components that we want to include in our circuit. So the first component is your power supply. So we click here at the corner here. So you see that there are trails of menus. So you just click any component that you are seeing here. Once you click that, you'll be taken to a window to select the components. So you can check the components here below. So we do have database. We are in the master database group. We are in sources, and in sources, this is where you are going to find your power supply. So we'll go to power sources and choose our AC power. Then once you click that, you are going to place the component on your workspace, and let us choose ground. We'll place ground below here. Then once you do that, you need to find a transformer. So we are stepping down our voltage to a certain limit that we can regulate it properly. So in order to do that, we'll go here to our basic group. So in this basic group, you go to transformers, choose the first one and place it here. After that, we need to go to diodes. So in diodes, that's where you are going to find our full bridge rectifier. So we'll go to diodes and go to full bridge rectifier, choose the first one and place it here. After that, we need to find two capacitors. So these capacitors are the ones that are going to fill our circuit. So we'll go to basic and go to electrolyte capacitors, choose the 10 micro. You place one here, and let's place one at the end of our circuit so that we do have nice filtered voltage. Then we'll actually go to find our voltage regulator. So we'll go to a group which is power, because our voltage regulator is in power section. We place the voltage regulator, choose the LM7805CT. So this one is the one that we on our last episode we talked about this, that it regulates the voltage to 5 volts. So let us choose this one and place it here. Then last but not least, let us choose a resistor. So our resistor is going to act like a load so that we can measure the potential difference of our circuit that we're working with. So we'll go to basic and press resistor, choose the 1K resistor, place it here. So it's very important to separate the ground from AC to DC, because if you put this in the same ground, you are going to have lots of noise in your circuit. So make sure that your grounds are separated. And to do this, we need to actually put go to sources and put a second ground to our AC side. Once you do this, your circuit is good to go. So the remaining part here is to connect and change some parameters. So what I will do, I will just connect these parameters and come back to you later. So we are done with our tracing. We have connected our components. So in this case, we just need to add 2 more components to measure our AC and our DC. So in order to measure our AC, we need to put an oscilloscope. So on the right side of Multism, that's where you can find your measuring instruments. We do have a digital multimeter here. And as you scroll along, you will see that you will find an oscilloscope. So we'll press the oscilloscope on this side to measure our AC. So to measure on our AC, we need to connect two junctions. So we'll connect the first channel. So the plus side, you connect it to the positive side of your supply, and the negative side, you connect to your ground part. So we have connected this oscilloscope to the input. We can also measure the voltage after stepping it down through the transformer. So it's just best practice to check if your transformer is working. On this side, we need to measure our DC, so it's as simple as connecting it to the supply, the output, and once you're done, you are nearly good to go. Then after this, we just need to change some parameters of our circuit. So the first parameter is our supply. If you double click it, we just need to change this to 230 to get in touch with our supply. So the list is fine. Then click OK. You go to the transformer. You are seeing that is 10 by 1. So we are transforming you are transforming it. You are stepping it down from 10th to 1 ratio. So that means if we are supplying 230, we are getting 23 volts. So let's just press OK for now, because our voltage that we need is 5 volts. So we are in the good range. After this, we are done. What we need is to just place this run button. So the run button, it's going to simulate our circuit. Then once we do that, let us check below here on our results. So you can see there are no errors here. If we go to simulation, you can see there are no errors. Spice netlist completed, 0 errors and 0 warning. So our job is not yet done. We need to see the results. Let us double click the oscilloscope. Again, you can see that we do have some output, but we can't see it clearly. In order to see it, we need to increase the scale. Right now it's 5 volts per division. So in this case, every box here that you are seeing here represents 5 volts. So we can't see the output since our voltage is 230 volts at the input. So we need to change also the voltage type to AC. It's in good practice, but our oscilloscope, it's in auto mode, so it can detect it on its own. Now you can check here, there is something else that you need to check. You can check that the limit here is coming at 230 and whatnot, but we do know our limit so far. Now, in order to change the division, you go and press here and increase the division. I think at 100 or 150, not 500, but at maybe 200, that means we can see something. Let us also increase here the division, maybe at 200 to check the results. So you can actually appreciate that we do have something going on here. Right here, what we need to do is to adjust the scale so that we can see the scale of our image in real time. But if you can take a look here at the voltage, they are in the same scale, and you can see that the channel A here, if we switch off the channel B by pressing this 0, you can see that our channel A is bigger than the channel B here that we do have. And in this case, it's showing that our transformer is working and that it stepped down the voltage. Let us double click the multimeter. You can see that our multimeter is producing 5 volts. So our circuit is working and we are good to go. You can tamper around with some other parameters of these components, but this is all we were supposed to do in this section, and we have achieved producing the AC to DC converter. So let's get back to EasyEDA and proceed with designing our circuit.